So down at the bottom of page 1 in 7.2, we've got some examples of learning how to factor 3 terms, and our steps, our goal in this particular method, what I'm going to present, it's not the only way to do it, but what I'm presenting is we're going to take these 3 terms, convert it to 4, and then use factoring by grouping. And the instructions that go with this say to use the method of your choice to factor each trinomial or state that the trinomial is prime. Check each factorization using FOIL multiplication. So since we're undoing the FOIL to factor it, of course you can refoil to double check that you got your factors right. You can do this in your head or you can do it on paper. So let's look at what our steps are, and then we'll practice it on each one. Okay, so for the strategic split down here in the corner, we're going to start by multiplying our A coefficient times our C coefficient. Again, we're starting with ax squared plus bx plus c as our standard form. So in this one, number 40, x squared minus xy minus 30y squared. Our A value is the one that's in front of this. Again, we're starting with ax squared plus bx plus c, where these are the numbers in front. Either the coefficients or the constants that we're looking for. So we've got a 1, we've got a -1, we've got a minus 30. So our A value here is 1. Our B value here is -1. Notice I take the sign with it, the sign that's in front of the number. And our C value is -30. And actually our C value, we won't worry about the sign in front of that one just yet. That will tell us something in a little bit. So we just take the positive value. We take the sign to on our B value and just the positive version of the C value. So our A value is 1, our B value is -1, and our C value is 30. And we're going to start by multiplying A times C. So our first step is to take A times C, which in this case is 1 times 30, which just gives us 30. And our second step after multiplying A times C is to list factor pairs of AC, the product that we just got, until we find a certain match. Now first we'll go ahead and list them, and then we'll work on what does that mean. We're looking for what multiplies to give you 30, and some of you will get to the point where you can do this part in your head. 1 and 30, 2 and 15, 3 and 10, 5 and 6. We're looking for a pair here, and all of these pairs multiply to give you 30, and these are all the possibilities here. Okay, so we're listing factor pairs of AC, and you can do this in your head probably once you get good at it and feel real confident, until you find a pair that either adds to equal your B value or it subtracts to equal your B value. So this sign will tell you whether you're adding or subtracting. Okay, so the sign in front of C tells you add or subtract. I apologize for the small writing here. I just want to make it all fit, and we'll talk through this over and over again until it starts to stick here. So you list factor pairs of AC until you find and use a pair of those factors, in this case 1 and 30, 2 and 15, 3 and 10, 5 and 6. You're going to find and use the pair that adds to equal your B value, and that's if your C value is positive, greater than 0, or find and use the pair that subtracts to equal your b value, and that's if your c is less than 0, it's negative. Well, in this case we have a negative 30, so we're going to find the pair that when you subtract them together, you get our b value. Our b value is negative 1. Okay? So we want, so our c value is less than 0, it's negative. So we want a pair that subtracts to equal b, which in this case is negative 1. So which of these pairs would subtract to give you negative 1? Well, if you took 5 minus 6, and order matters here, so it'd be a 5 and a negative 6, that equals negative 1. So this is the pair we're going to use, 5 and negative 6. 5 and negative 6 is our pair. So we took our c value, we listed either on paper or in our head the factors. We picked the pair of those factors, meaning 5 times 6 equals 30, 3 times 10 equals 30, 2 times 15 equals 30, 1 times 30 equals 30. We picked the pair that subtracts. Why subtract? Because the sign in front of the 30 was negative. That subtracted to get us our b value in front of the middle term, the negative 1. Again, our goal here is so that we can split this middle value strategically to create 4 terms that we can factor by grouping. Okay, so this is now the split. So our next step will be then to split the b term using that pair that we just discovered. And here's the very, very important part. We're going to keep the signs. So when we said it was a 5 and a negative 6, or a 5 minus 6 that would give you the negative 1, then we have to make sure that we use it as a positive 5 and a negative 6. If we were trying to find a positive 1, we would take 6 minus 5, which means the minus would stay with the 5. It'd be a positive 6 minus 5. So that's why we want to keep the signs here. Well, what does that look like? Well, that looks like this. We're going to take this pair, this negative 1 xy, and we're going to split it. It's going to become 5xy and minus 6xy. That equals negative xy. So we aren't changing anything, we're just doing a strategic split. Okay, so we still have our plain old 1x squared plus our 5xy minus our 6xy, and we still have our minus 30y squared. So what we've done is we've changed our 3 terms to 4 terms. Okay, so now it's 4 terms, and once we have the split, then we factor by grouping. And I'm just realizing that even though we've gotten boringly good at always checking for the GCF, I didn't start by doing that. I should have checked all 3 terms by checking for a GCF in the beginning. There's not. In fact, there won't be for a little bit until we get better at this. But we always want to check for a GCF first, and then we ask how many terms. Well, there was 3, so we're going to change it to 4. So GCF came first. No. Terms, there were 3. We're going to convert to 4. How? We do the strategic split. And it seems like a lot at the beginning, but once you get the rhythm of it, you'll get faster and it'll become really automatic. And you'll see that factoring is really not that hard. It's one little search for a strategic split pair. Okay. From here, we now have 4 terms. We can factor by grouping. Look at what the first 2 have in common. Look at what the second 2 have in common. And my suggestion is, if you haven't done the homework for factoring by grouping yet, pause here, come back to this video after you've accomplished the homework for 7.1b, after you've gotten really good at factoring by grouping. That will really help a lot. Then you're only trying to learn about the split here and not trying to learn about the split and factoring by grouping. Okay. So what do these first 2 have in common? X squared and 5xy. They have an x in common, leaving behind an x plus 5y. We're undistributing or factoring out that GCF of these first 2 terms. We look at the second 2 terms, and because the lead term is negative, we're going to pull a negative value out of there. Because again, we're expecting to make a match here. And if you forget about pulling out a negative, you'll notice it's close, but not an exact, oh yeah, I remember now, I'm supposed to pull a negative. So They have a 6 in common. 6 goes into both 6 and 30. They have a y in common, so we're going to pull out a 6y, and we pull out a negative 6y because the lead term has a minus in front of it. Okay? What does that leave behind? Well, negative 6y times x will give you the negative 6xy. Negative 6y times a positive 5y, again, shouldn't be too much of a shocker. We should expect a match here, so that's a great way to see, did you pull out the right GCF? It's a great kind of check within the problem itself. Think about dividing each piece by the GCF, or what would I get if I had to redistribute. However you want to do that to get that middle, what's left over here, the x plus 5y. We now have a match. Kind of zoom out, think big picture. What does this whole thing have in common now? This first half and this second half? Well, they have an x plus 5y in common. Pull that out, leaving behind the x minus 6y. Okay, so this is what we're pulling out, the x plus 5y, and then the x minus 6y came from what was left over here when we pulled away the GCF. And that's your factored form, x plus 5y times x minus 6y. Some of you may have been taught to draw the parentheses, put an x, and then put a y and a y, because there's a y squared as well, and then mess around with 30, all the different combinations of 30, until you get an outside-inside to match this. It's essentially what we're doing, except we're not messing around inside here. We're actually just listing it all out until, boom, we know we've got it. We don't have to put it in and hope that it's right and check it. We know it's right based on what we did. So it's a little variation of what you might have been taught how to do this. Let's look at number 26. Okay, x squared plus 4x minus 10. Again, standard form is ax squared plus 4x minus, ax squared plus bx plus c. So our a value here is 1, the number in front of x squared. Our b value is a positive 4, and our c value is 10, and it is negative. Okay, we'll use the negative part later. Because we keep the sign of the b value, we just take the positive value of c and note the sign. Okay, so we keep the sign of b to use. We want to create a positive 4. We just note the sign of c. It's negative. Okay, because that'll tell us that we're going to subtract. We ask ourselves, does it have a GCF? Is there anything that all three have in common? Because we want to get boringly good at factoring. Okay. How many terms? Well, there's 3. Nothing in common. There's 3 terms. We're going to convert to 4. That's what we're practicing in this section. So how do we do that? Well, we're going to start by multiplying a times c. So the first thing we do is we take a times c, which in this case is 1 times 10, or just 10. And then we're going to list factor pairs of AC until we can find a pair that either adds or subtracts to B. Now, how do we know if we want to add or subtract these pairs? Well, the sign of C is negative, so we're going to try to subtract this pair. So let's first break it down into pairs here. 1 times 10 is 10, 2 times 5. Not many choices here. So we are going to, actually I should have written down at the beginning here. I guess I did up top. A equals 1, B equals 4, C equals 10. So A equals 1, B equals 4, C equals 10, and it's negative. Okay, so that tells us we're going to subtract. Okay, so is there any of the, now you look for the pair that if you were to subtract it, you could get something minus something equal to that positive 4. Is there any pair that works? No pair works. You can't go 1 minus 10, that's negative 9. 10 minus 1 is positive 9. 2 minus 5 is negative 3. 5 minus 2 is 3. Nothing gives you 4. Okay? So if there's no pair that works, you may stop. This one is prime. This one is not factorable. So there was no GCF to pull out. There was no way to split it to factor the 3 terms as a to convert it to 4 and then factor by grouping. So this particular one is not factorable. It's prime. Kind of like the number 13. You can't break it down into whole numbers, something times something. It's just prime. It just is. is that? Okay. I'm sorry, we're getting some more sun here, I'm realizing as I'm doing this. Let's see if I can, sure I can adjust it as we go. I will slide this over so we can see this example. Maybe that'll help. That's not really good at all. I may have to do the rest of this recording after the sun gets out of the way here. Okay, well, let's try this question, and then if you want to see it in class again, I'm happy to do it again. So take a moment to talk through this, explain it to somebody or talk it out loud for yourself, copy these steps, copy these problems, try them, and then here's one for you to try on your own. So you'll want to pause the video in just a moment, try number 62, and note that I threw in one here to stretch you a little bit. We're being boringly good. How? By checking for the GCF first. That's the very first thing we should check for, and then we ask ourselves how many terms. Now this is boring because a lot of times there hasn't been a GCF, and when we're in a particular section it's always the same answer for how many terms. In this case 3, so we're going to convert to 4. Earlier sections it was always 2 or it was always 4. Now it's going to be always 3. But I threw this one in because it does force you to ask this question. So start here, does it have a GCF? Then move on, do the number of terms, and it's 3, so that means we're going to convert to 4, so you can do grouping, and then come back and we'll see what the answer is in a moment. Okay, so you've unpaused the video, you've given this a chance now. The GCF, I tried to give you a little hint here, it does have something in common all the way across. So there is a GCF, and I'm going to work this one out so that you can see it. It is 3w squared is what they all have in common, and what that leaves behind is w squared plus 18w plus 45. So you take a 3w squared out. All three of these numbers are divisible by 3. 5 plus 4, add the digits, that's 9. 9 is divisible by 3, so 3 goes into 54. You know that trick? Add the digits, 1, 3, and 5. 1 plus 3 is 4, 4 plus 5 is 9. 9 is divisible by 3, so this big number is divisible by 3, 135. So 3 goes into each of these, w squared, so pull out the GCF. Now how many terms are left inside here? And we want to just make sure that 3w squared makes it all the way into our answer. We don't want to leave that GCF out, so I'm going to leave it, I'm going to bring it down right now. How many terms are left over? There's 3, which means that what we're going to do is we're going to convert it to 4 so that we can factor by grouping. Now, is this the only way to do this? No. There's several ways you can approach factoring, but this is what we're going to do in these examples. You're welcome to approach it any way that makes sense to you and is getting you consistently the right answers. Okay. So we're going to start by identifying our a, b, and c values. Our a value in front of the squared piece is 1. Our b value is 18. It's positive. We keep that sign. Our c value is 45, and then we note the sign of that one. It's positive, which means we're going to try to add. Add what? Well, we're going to take our a value times our c value. For now, your a values, you'll notice, are going to be 1. So when we move into 7.3, your a will not be 1 anymore. It'll get a little bit more exciting. But for starters, we'll just start with our a value of 1. So our a times c is 1 times 45. That gives you 45. Now we're going to look to split 45 into pairs, multiplying factors here. What times what gives you 45. Looking for a pair that when you add them together, you'll get 18 as your answer. Some of you will be able to do this in your head. Some of you will need paper for this process for a little while. 1 times 45 is 45. It's not even, so 2 doesn't go into it, but 3 times 15, 4 doesn't go into it, 5 times 9. Those are your options. Some of you will be alert enough as soon as you see the pair that works. 3 plus 5 does give you 18. You can stop your list because there will only be one pair that works. And if there is no pair, like we saw in the previous example, it's prime, not factorable. As soon as you find the pair, you can stop the list. And then we split that middle term strategically here. So now that 18w is going to split into 3w and 15w. So what we're trying to factor here now is the w squared plus 3w plus 15w plus 45. Notice I'm not worried about 3w squared. It was a GCF. I pulled it out. It's going to be part of our answer. I'm just trying to factor this now. So what I've done is I've converted it to 4 terms, and now I can factor by grouping. What do the first two have in common? Well, they have a w in common, leaving behind w plus 3. The great thing about factoring by grouping is this gives me a hint of what I'm going to match. I'm going to expect to see w plus 3 show up. So what do the second two have in common? They have a 15 in common. 15 goes into 15 once, goes into 45 3 times. Divide out that 15 greatest common factor, I'm left behind with w plus 3. Shouldn't be a big shocker. We expected this to match. That's what factoring by grouping does for us. So we pull back, so to speak. We've already got our initial GCF of 3w squared. We now have a second GCF of w plus 3. And when we pull that out, it leaves behind the w plus 15 as our last factor. So the final version of this is 3w squared times w plus 3 times w plus 15. And we just do a quick check. W plus 3 can't go any further, and w plus 15 can't go any further. It's 2 terms, but they don't match the difference of squares, difference of cubes, or sum of cubes situation. Okay, so that would be our answer on that one. Okay,